Hi, this is part one of the Newton's Laws test review, where we're going to talk about Newton's first law and types of forces. So Newton's first law, you're probably familiar with it. It says something like, if an object is at rest, it will remain at rest. And if an object is in motion, it will remain in constant motion unless it's acted on by an outside force or unbalanced forces. I capitalize constant because that's important. Objects in motion will not just continue in motion, but they will remain in motion as they are, moving in a straight line with a constant speed, unless acted on by forces. So to change the motion of an object, you need unbalanced forces. So if it's at rest, to make it move, that would be changing its motion. You have to act on it with unbalanced forces. If it's in constant motion and you want to speed it up, slow it down, or have it change direction, that also requires unbalanced forces. Which brings us to the word inertia. Inertia is a resistance to change in state of motion. So resistance, okay. So my writing tool isn't doing real well. So let me open up the text bar. So inertia is resistance to a change in state of motion. So things like to keep doing what they're doing. If they're stationary, it is their nature to remain stationary. And if they're moving, it is their nature to remain moving, just as they're moving, the same speed, same direction. And inertia is that characteristic of matter that it resists changing its motion. Inertia and mass are related. Mass is a measure of inertia. That over here. Mass is a measure of inertia. Mass has units of kilograms. And it is, if something has more mass, then it resists a change in its state of motion more than if it has a small mass. So mass and inertia are very tightly related things. Mass is like the numerical quantity of inertia. So now we'll talk about these unbalanced forces. A force, as you know, is a push or a pull. The unit of forces is the Newton. 1 Newton is equal to 1 kilogram meter per second squared. So the force unit is the Newton. The mass unit is the kilogram. And the meter per second squared, that's an acceleration unit. And it's very important that you know what these units are. Which one is what? That this is your force unit. Okay, I'm going to make this thing work. Force unit. And the kilogram is a mass unit. And this meter per second squared, that's an acceleration unit. Okay, and that is a C, right? ACC. Okay, an acceleration unit. So there are two main types of forces. You have contact forces and field forces, and another name for field forces is at a distance forces. So contact forces are forces where things have to be touching for the force to happen, and field forces are when things don't have to be touching. So if we look at these kind of basic forces that we deal with, friction, the normal force, remember the normal force is a force that's perpendicular to a surface. So if I have a box that is sitting on a surface, the box is pushing down on the table, and the table exerts a normal force upward, perpendicular to the surface. That's what the word normal means, is perpendicular. So that normal force would be perpendicular to the surface of the table. Tension is a force in a string or a cord or a cable, something like that. Gravitational force, well, if we look at these four, friction, normal, and tension all require contact. So those are contact forces. The gravitational force does not. The moon and the earth are attracted with the gravitational force, and they're not touching. They are at a distance. So the gravitational force is an example of a distance or a field force. And applied forces are forces that we apply. So if there was a person standing behind this box trying to push that box that way, he would be pushing with an applied force. Okay, before we move on to part two, let me make sure there's nothing else I want to talk about in this part. Okay, so a force is a push or a pull. We know our units. The questions on the test about this unit will be concept questions. There won't be, not about this unit, but about this section. There'll be concept questions about what does Newton's law say? What is inertia? What is mass? What are the units of force? What are the units of mass and acceleration? What is the difference between a contact force and a field force? And give an example of those things. The other field force is the electrostatic force or electromagnetic force. And I don't know if I can write that EL. I'm going to say electromagnetism. That's close to electromagnetism. So electric force and magnetic forces, those are also at a distance forces. Anything that there's a field associated with, there's gravitational fields, electric fields, magnetic fields. If there's a field associated, then objects can act on each other when they are at a distance. All right, well, that sums up part 1. If you need any more detail, look back through the newsfeed or go back and look at the recorded sessions, the recorded synchronous sessions, where I have recorded tutorials on an introduction to Newton's laws, and you can read all about different types of forces, or not read, but listen to information on the different types of forces there. Okay.